Okay, you're given this implicitly defined function right here. Asked to find y prime using implicit differentiation. And then also to solve this function for y in terms of x, which I've done right here. All I did was isolate that term by taking these terms to the other side of the equal sign and then dividing by x. Take the derivative of defined and kind of show that they're consistent. So for this first implicit differentiation, we have to use the product rule on this term. So the derivative of the first function, x is 1, times the second function, plus the first function times the derivative of the second. And then for these are just straightforward with respect to x, 2, 6x, and the derivative of negative 5 is 0. Take all of these terms without y prime to the other side of the equal sign, then divide by x. If you want to, you can move the minus sign out front. So in terms of x and y, there's the first derivative. For f prime, you have to use the quotient rule. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. I could put a 1 here to show that I took the derivative of the denominator all over the denominator squared. If you remove parentheses, combine similar terms, this is what you end up with. And this little table kind of shows that, I don't have g of x, y in here, but I'll show that on the next screen. But h sub 3 is shown on the next. No, it isn't. Oh, this is h sub 3 right here. Right here. Okay, so that's the derivative. It's the same as f prime. So if I come over here, there's the graph of the original function. Both explicit and implicitly defined, they're the same graph. I set x of 1 equal to some value in the domain of the function and plot the point x of 1, f of x of 1. There's the equations of tangent lines. And here's where I've kind of proven that the implicitly defined value of the derivative, g of x comma y, gives the same tangent line as using the explicitly defined derivative. And if you go to Desmos, which I'm going to provide the link to this graph, you can move this point around and you'll see that both of these tangent lines are always the same. Okay, there you go. Hope that helped. If you have any questions, post a comment.